All right, here's the last video for the review on Unit 8. We're going to cover questions number 21 and 22. In 21, we've got a curve that's represented by y equals x to the n. And then we have a tangent line L, it says. And then we have the point of tangency, which is 1, 1. And then they drew the vertical line here. So we have region S and region T. For part A, it says find the integral from 0 to 1 of x of n dx. Okay, so the integral from 0 to 1 of x to the n dx. And so the first thing we have to identify is what is the variable and what are all these letters representing. So x is a variable because we're taking the integral in terms of x. N is going to be a constant value because in the instructions it says that y equals x of n where n is greater than 1. So n basically can be anything as long as it's greater than 1. So analytically, we're going to take this integral. The way we do this, because this is polynomials, we're going to do the reverse power rule. Well, the reverse power rule says you add 1 to the exponent, so that will say x of n plus 1, and then you multiply that by the coefficient, which is 1, divided by the new exponent, so n plus 1 out front, and then you evaluate that from 0 to 1. And so when we go to solve this, we're going to plug 1 into x, we're going to plug 0 into x and subtract. So it's 1 over n plus 1 times 1 to the n plus 1 minus 1 over n plus 1 times 0 to the n plus 1. All right, we can simplify this further. It says that n is greater than 1, so 1 raised to anything, that'll be greater than 2. 1 raised to anything will be 1, and so you're left with 1 over n plus 1 for this first term. The second term, 0 raised to, if that's greater than 1, that means when I add 1, that'll be greater than 2. 0 raised to anything greater than 2 is going to be 0. So we get 1 over n plus 1 times 0. And so that all cancels out, and you're left with 1 over n plus 1 as a final answer. So point values on this guy, you would get 2 points for this. 1 point for showing the correct antiderivative. All right. So that would be this expression right here, showing the reverse power rule. And then 1 point for your final answer. And obviously, you're not going to get a point for your answer unless your work actually makes sense. Okay, so that's part A. Part B says let T be the triangular region bounded by the line L, the x-axis, and the line x equals 1. Show that the area of T is 1 over 2n. That is a little tricky one here. So show that the area of T is equal to 1 over 2n. Well, think about what it means to be the area of a triangle. The first thing I'm going to note is that the area of a triangle is 1/2 base times height. And so in this triangle, we've got it pretty easy in terms of the height here. The height is just 1, so that's nice. I'm going to replace that here. And so the big question is, what is B? The B represents the base of the triangle. So the B represents the distance from this x-intercept to this. So that's B. Well, we already know that this value is 1. We've got to figure out what this value is. So what we're going to have to do is show the equation of this tangent line, I believe, and then find its x-intercept. So the equation of that tangent line is, you remember you need 2 things to create a tangent line. The first thing is the point, which we have. The second thing is the slope. Well, the slope is dictated by the derivative of the curve that it's tangent to. So the first thing we have to do is take the derivative of our curve. The derivative of this curve is going to be n times x to the n minus 1 because we're using the power rule there. So remember, you multiply the power to the front coefficient and then subtract 1 from the power. So that's the derivative. And we're trying to figure out that value at the point of tangency, which is 1. So we're going to say y prime evaluated when x equals 1 is equal to n times 1 to the n minus 1. And again, n is greater than 1, so this will be 1 to some value, which is 1, and then our final answer there for the derivative is n. All right, so now our tangent line, the tangent line is going to be y minus 1, because that's our y value there, equals to the slope, which is n, times x minus 1. So that is our equation for the tangent line. And we need to figure out this point, which is the x-intercept. So to find that x-intercept, we're going to set that y value equal to 0. So we set that equal to 0, and then solve for x here. Let me go ahead and, well, I'll divide by n here, so I get negative 1 over n equals x minus 1. Then we'll add 1, so negative 1 over n plus 1 equals x. So I know, let me go ahead and write this in here. I know that this point right here is negative 1 over n plus 1, and this point here is 1. So in order to find the length of b, I need to subtract those values. So I'm going to write that. We're going to say that b is equal to 1 minus all of that. 1 minus negative 1 over n plus 1. And then we can simplify that by distributing the negative. So you get 1 plus 1 over n minus 1. And then we simplify that by saying b is 1 over n. So since I know my b value, I can plug that in here. The area of my triangle is going to be 1/2 of 1 over n, and then times 1. So that simplifies to 1 over 2n. And there we showed the area of the region T. Now, there might have been different ways to approach that, but that's how I saw it. So if you saw it a different way, as long as it mathematically makes sense and you're expressing yourself well, you're probably good. This problem was worth 3 points. 1 point for the slope of line L. So basically, if you got to this point, you got the slope of line L, which is n. 1 point for the base of t. So you would have gotten 1 point for 1 over n there. And then 1 point for showing all the work that leads to the area. So 3 points for that problem. All right, so for problem C, it says let S be the region bounded by the graph y equals x to the n, the line, the tangent line L, and then the x-axis. It says express the area of S in terms of n and determine the value of n that maximizes the area of S. So there's a lot going on in this problem. But the first thing we need to do is figure out an expression that represents the area of region S. Now, we did a problem like this a little bit ago. If I were to break this apart, it could get kind of complicated if I draw a vertical line there. So what I'm going to do instead is I'm going to find the area of this region, which is the area under x to the n, all the way from 0 to 1. And then I'm going to subtract the area of that triangle there, and that will give me the area of region S. So the area under this curve is going to be the integral from 0 to 1 of x to the n dx. And then the area of the triangle here we just did, that's 1 over 2 to the n. Well, back in part A, we actually evaluated the integral from 0 to 1 of x to the n dx, and that was 1 over n plus 1, and then we got minus 1 over 2n. So this is an expression that represents the area. So that's going to give you some points there. I'm going to go ahead and write that up here because I'm going to have to do more with it. It says, now that you have that area expression, you want to maximize the area of S. In fact, I'm just going to call this S, area of S. I want to maximize. Well, we haven't done optimization in a while. So if you think back to finding a maximum of something, you have to take the derivative. You have to find all the critical points. So you're going to set the derivative equal to 0 and does not exist. And then you're going to evaluate each one of those critical points. All right, so now taking the derivative of this, we're taking the derivative of S in terms of n. Now before I do this, I could go through a big long quotient rule thing, but I'm going to just rewrite these to have negative exponents. So this will be n plus 1 to the negative first, and this can actually be rewritten as 1 over 2 and then n to the negative first. So I kept the 1/2 fraction and I just moved the n up. And then from there, we take the derivative in respect to n. So this is going to be negative 1 times n plus 1 to the negative second, and then times the derivative of the inside, which is just 1. The derivative of this guy is going to be plus 1/2 n to the negative second. And then I'm going to rewrite this just a little bit. So this will be negative 1 over n plus 1 squared plus 1 over 2n squared. Okay. So the first thing I'm going to note is one set of critical points. One set of critical points are when the derivative does not exist. Well, the derivative does not exist when we're dividing by 0. So if n is negative 1 or if n is 0, then we have a problem here. Now, the good thing is that in the very beginning of the problem, it said that n is greater than 1. So actually, these aren't going to be critical points at all because they're outside the domain. The next set of critical points is when you set s prime equal to 0 and then solve for n. So we get this guy here. Now, to solve this, this is not a calculator problem, so it's going to take a little bit of work. First thing I'm going to do is I'm going to move this over here. So you get 1 over n plus 1 squared equals 1 over 2n squared. I'm going to cross multiply, so you end up with 2n squared equals n plus 1 squared. Now, I could expand all of this out and move everything over to one side, but that's going to get gross, and it's not going to be solvable through a factoring method. But what I do notice is that I can solve for n directly here because both sides have a square on it. So I'm going to go ahead and square root both sides. And so you end up with, this guy turns into n rad 2 equals, and on this side, n plus 1. And of course, we need a plus or minus here, just to be careful. And then we're going to solve for n. So I'm going to move this guy over here. So that's going to be negative n plus or minus n rad 2 equals 1. We'll factor out an n, so you get n times negative 1 plus or minus rad 2 equals 1. And then we'll divide all that. So n equals 1 over negative 1 plus or minus rad 2. So that is n. Now, it does say that n is greater than 1. So n is greater than 1. If I subtract rad 2, I'm going to get a negative number here. So I'm just going to add rad 2, and that's my value for n. Now, the good thing is that is our only critical point. So if we were going to set up a number line here, we know that 1 is the end point, and then 1 over negative 1 plus rad 2 is my 1, 0 here. You know, what value can I plug in on this side? Well, you could plug in 1, because the only reason it's a critical point is because it's an endpoint. If I plug in 1 to my function, sorry, to my derivative, if I plug in 1 here, I'm going to get negative 1 over 2 squared plus 1 over 2 times 1. So I get negative 1/4 plus 1/2. That's going to be a positive value. If I plug in, I'll plug in something really big, like, I don't know, 10. So I get negative 1 over, I'll plug in 9. 9 plus 1 is 10, squared is 100, plus 1 over 2 times 10 squared is 100. So negative 1 over 100 plus 1 over 200 is actually going to be a negative value. So you can see that there is an absolute max at this n value because s prime is strictly positive in this domain and strictly negative in that domain. Fortunately, it didn't say to justify any of that. It just wanted the value of n. And there it is. That was a bear. Point values here, you get 4 points for this problem. 1 point for expressing the area of S. So you get 1 point for this guy. You would get 1 point for taking the derivative correctly. So 1 point for this guy. You get 1 point for setting that equal to 0. And then 1 point for your final answer. So you can see that you got through most of the work, most of the points based on the calculus stuff. The area expression, the derivative, set the derivative equal to 0. All of this is algebra, and it's only worth 1 point. So, all right, that's the end of number 21. Okay, for number 22, in a way, this is going back and covering Unit 7 a little bit, but we'll see how that plays out in just a minute. We have a differential equation, dy dx is equal to y squared times 2x plus 2. And it says f of x is the particular solution where the initial condition is f of 0 equals -1. All right, for part A, it says find the limit as x approaches 0 of f of x plus 1 over sine of x. And then it says show the work that leads to your answer. So remember, the first thing you do when you're trying to take a limit is to substitute. So when I go to substitute here, I'm going to get f of 0 plus 1 over sine of 0. Well, f of 0 was given by this statement here, so that's -1 plus 1. Sine of 0 is 0, so we end up with 0 over 0. So here we have an indeterminate form. So what do we do when we have an indeterminate form? We do L'Hopital's rule. So we're going to say, therefore, L'Hopital's rule applies. All right. Remember, you have to make those statements. You have to check for substitution. If you get 0 over 0 or infinity over infinity, you have to state it's indeterminate, and then you have to state, therefore, L'Hopital's rule applies. If you don't, you're going to be missing some points here. So remember, L'Hopital's rule, once it works, once we know it works, is the same, the limit is the same as taking the limit of the derivative of the top times the derivative of the bottom. So the derivative of the top is just f prime of x. The derivative of the bottom is cosine of x. Now, this gets a little weird in terms of the expression, but I like the notation. It helps us understand calculus in a more complete way. What is f prime of x? Well, f of x is the general solution for this equation, which is implying that f prime of x is this. So if I'm going to plug in 0 here, let me go ahead and plug in 0. It'll be f prime of 0 over cosine of 0. Well, I know cosine of 0 is just 1, so I've got that. F prime of 0 is plugging in 0 for x into this equation. Well, you might go, well, wait a minute. I don't know what this derivative is going to express because I don't know what y is. I only know what x is. Well, when x is 0, you know y is -1. So I'm going to go ahead and show that work off to the side here. We're going to say dy dx evaluated at 0, -1 is -1 squared times 2 times 0 plus 2. And then we can simplify that a little bit. That's going to be 1 times 2, which is 2. So that is our derivative at that point. So that is f prime of 0. So we get 2 over here, which means our answer is 2. As far as points go, this is a 2-point problem. You're going to get 1 point for doing L'Hopital's rule. So you're going to get 1 point for basically getting down to this point, and then 1 point for the answer. Okay? So there's a lot of work, a lot of stuff that needs to be stated before you get to this point. Check substitution, see it's indeterminate, state it, and then state L'Hopital's rule applies, and then actually do L'Hopital's rule by taking the derivative of the top and the derivative of the bottom, and then you would plug in, and that's where you get your last point. So that's part A. Oops, don't want to erase all that. Part B, let's see, that was -1 here. Part B says find f of x, the particular solution to the differential equation. So we're trying to solve this. We're trying to figure out what y equals because it says y equals f of x. So in order to solve this, our first step is to separate the variables. So this is going to be 1 over y squared dy equals 2x plus 2 dx. We'll integrate both sides. Well, there's a common tendency to say, oh, that's natural log. We've said this multiple times. It's not natural log because the only time it is natural log is when the exponent on the bottom is 1. So what we have to do first is actually rewrite that as a negative exponent before we take the antiderivative. So the antiderivative of this is going to be y to the negative first with a negative out front. The antiderivative of this is going to be x squared plus 2x plus c. And then from here, I'll just rewrite this as negative 1 over y equals x squared plus 2x plus c. From here, we're going to figure out what c is. So we have to take our initial condition and plug it in here. So the y value is negative 1. The x value is 0. So plug those in. And then simplify. So negative 1 over negative 1 is 1. That all zeroes out, so your c value is 1. And now we're going to take that and plug it back in here to solve. So you got negative 1 over y equals x squared plus 2x plus 1. And because we're actually looking for y equals, we have to solve this from here. So I think the easiest way to see this is to just put this over, well, I'll do it this way. I'm going to multiply both sides by y. And I'm not going to distribute over here. On this side I get negative 1, and on this side I get y times x squared plus 2x plus 1. And then I'm going to divide by this whole thing. So we end up with y equals negative 1 over x squared plus 2x plus 1. And that is our final answer. As far as points go, this is a 5-point problem. It's a big one. You get 1 point for separating the variables. So 1 point for that line if you did it correctly. 1 point for the antiderivatives. So getting to this line, you're going to get 1 point for taking the antiderivatives. Okay. You're going to get 1 point for the plus c, the constant of integration. You're going to get 1 point for using the initial condition and figuring out what c is. And then you're going to get 1 point for your answer here. All right, so 5 points there. All right, that wraps up the review for Unit 8. I hope that helped you out. If you have any questions, comment below or email me, and I'll be glad to help you out. With that said, study hard and prepare well.